Example 11.3. A sphere of aluminium of 0.047 kilogram placed for sufficient time in a vessel containing boiling water so that the sphere is at 100 degrees Celsius. It is then immediately transferred to 0.14 kilogram copper calorimeter containing 0.25 kilogram of water, which one is at 20 degrees Celsius. The temperature of water rises and attains a steady state at 23 degrees Celsius. Then calculate the specific heat capacity of aluminium. Now aluminium sphere that is at 100 degrees Celsius, and when it is placed in the water, so aluminium sphere will lose the heat, and the container copper calorimeter, that is the container, and water will absorb the heat. Okay. Now, due to loss of heat, the temperature of the sphere reaches to the 23 degrees Celsius, and by absorbing the heat from it, the system made by copper and water, its temperature increases up to 23 degrees Celsius. When all the constituents of the systems are at 23 degrees Celsius, means all are at the same temperature, then we can say the steady state is attained. Then after there will be no exchange of heat. Now see, mass of aluminium sphere, that is 0.047 kilogram. Then initial temperature of aluminium, that is 100 degrees Celsius. Final temperature of aluminium, that is 23 degrees Celsius. So change in temperature of aluminium, that is 100 minus 23, that is 77 degrees Celsius. Now mass of copper calorimeter, that is 0.14 kilogram, mass of water MW, that is 0.25 kilogram. Now initial temperature of the system made by copper and water, that is 20 degrees Celsius. Final temperature of the system, means of copper plus water, that is 23 degrees Celsius. So increase in the temperature of copper plus water, that is 23 minus 20, that is 3 degrees Celsius. Specific heat capacity of aluminium that we want to calculate, specific heat capacity of water, and specific heat capacity of copper that we have to take from the table are constants. Now first of all, consider the heat lost by aluminium sphere. So heat lost by aluminium sphere, delta Q aluminium, that is specific heat aluminium, mass aluminium, and change in temperature of aluminium. Now heat gained or absorbed by the system made by copper and water, that is delta Q heat absorbed by copper plus water, that is some part of that heat is utilized to raise the temperature of copper, some part is utilized to raise the temperature of water. But temperature of copper and water both are raised by the same amount, 33 degree. So here we can write specific heat of copper, mass of copper, delta T, copper plus water, plus specific heat water, mass water, delta T, copper plus water. But here the amount of heat lost by the sphere, the same one is absorbed by the copper plus water. So we can write delta Q aluminium, that is delta Q copper plus water. So compare this equation and this equation. So specific heat capacity of aluminium, mass aluminium, delta T aluminium, that is S copper plus S water, mass water, delta T is taken common for copper plus water because that is same one for both. Now, specific heat capacity of aluminium, mass aluminium, that is 0.047. So we can write that is 47 into 10 raised to minus 3. Temperature change for aluminium, that is 77. Specific heat capacity of copper 3.86 into 10 raised to 2. Mass of copper 0.14 kilogram. Then plus specific heat capacity of water 4.186 into 10 raised to 3. Then mass of water 0.25 into change in temperature of the system of copper plus water, that is 3 degrees Celsius. So now solve this one, make SAL as a subject. You will get the specific heat capacity of aluminium.